All right, let's talk about something that could totally change the way you revise for your AQA GCSE Physics exam. We're going to dive into a method that helps you connect all those different topics, making your revision way smarter, not just harder. So, if you're deep in exam prep, this probably feels familiar, right? You've got energy, electricity, forces, waves, atomic structure, and it can feel like this massive random list of facts you just have to cram into your brain. You start to wonder, how on earth does it all fit together? Well, here's the game plan. We'll start by looking at this revision puzzle. Then I'm going to let you in on a secret, AQA's 6 master keys, hidden right in the specification. We'll group them into 3 really powerful pairs: models and maths, cause and change, and fields and forces. And the best part? We'll finish up by showing you exactly how to use these keys to unlock those higher marks in your exams. Okay, so let's start with that puzzle. Seriously, how does the particle model of matter have anything to do with the life cycle of a star? What does the motor effect really have in common with radioactive decay? When you revise topic by topic, it can honestly feel like you're learning 5 different subjects. But what if I told you that the exam board, AQA itself, has already given you the secret? The key is hidden in plain sight, tucked away right in the specification document in a little section at the very end called Key Ideas. Now, before you start to panic and think, oh no, more stuff to learn, stop. This is not more content. Think of this section as a set of 6 master keys. These aren't new topics to memorize, they're the fundamental principles that connect the entire subject. They show you the patterns that run through all of physics. And look, you don't have to take my word for it. This is a direct quote from AQA's own specification. They're telling you that all this complex stuff can be described with just a small number of key ideas. They are literally handing you the cheat sheet for how physicists think. So, here they are, the 6 key ideas. I know, at first glance, it might just look like another list to memorize, right? But stick with me. To make this really powerful for your revision, we're going to group them into 3 memorable pairs that are so much easier to get your head around. Let's kick things off with our first pair, models and maths. You can think of these as the absolute essential tools in a physicist's toolkit. They're the blueprints and the language they use to describe the world. First up, models. Now, a scientific model isn't the real thing. It's a simplified representation that helps us understand something really complex. Think of it like a map of London. It's not actually London, but it's a super useful sketch that helps you navigate and predict your route. And the thing is, you've been using this key idea all along, without even thinking about it. When you draw particles in a solid, you're using a model. When you think about light as a wave, that's a model. The plum pudding and nuclear models of the atom? Perfect examples of how these models get better as we get new evidence. And that brings us to the perfect partner for models, maths. If models are the blueprints, then mathematics is the precise language written all over them. It's what turns a descriptive idea, like a force makes things speed up, into a precise predictive law you can actually use. F equals ma. Okay, on to our next pair, cause and change. If models and maths are the tools to describe the universe, then this pair represents the engines of physics. These are the principles that explain why things happen and change in the first place. So key idea number 2 is cause and effect. At its very core, physics is all about if this, then that. You do something, that's the cause, and something else happens as a result, that's the effect. It is the fundamental logic of how the whole universe operates. And you see this everywhere in your syllabus. You apply a resultant force, the cause, and you get acceleration, the effect. An unstable nucleus changes, the cause, and it spits out radiation, the effect. This simple logic underpins so many of the topics you've studied. So you start to realize that change doesn't just happen randomly. It's always driven by something, and that something is almost always a difference. Thermal energy flows from hot to cold because of a temperature difference. Electric current flows because of a potential difference. This single idea is the universal reason for nearly every single flow or change in physics. Our final pair. This one tackles one of the most mind-bending yet essential concepts in physics. How can things affect each other across totally empty space without ever touching? Welcome to the world of fields and forces. This is key idea 3, action at a distance. How does the sun keep the Earth in orbit? How does a magnet magically pull a paperclip towards it? The brilliant answer physicists came up with is the concept of a field, an invisible region of influence that an object creates in the space around it. And once you really get this idea, you'll see it connects three massive topics in your course. The force of gravity, all the stuff with magnets, and the forces between electric charges are all explained using the exact same model of a field. It's one concept that unlocks three different areas of physics. Now, the partner to action at a distance is proportionality. This might sound a bit simple, but it is incredibly powerful. It just means that as one quantity changes, another one changes with it in a really predictable, constant way. You double the force on a spring? Guess what? You double its extension. It's that simple. And this isn't some abstract idea. It's built right into the equations you use every single day. Weight is proportional to mass. Force is proportional to extension. Those little letters, G and K, they're literally called constants of proportionality. So every time you use these equations, you're using this key idea. Okay, so this framework is great for understanding physics, but let's be real, how does it actually get you more marks? Let's get into the good stuff, how you can use these master keys to totally unlock exam questions.
Here's a simple three-step strategy you can apply. First, when you read a question, play detective. Ask yourself, which of these key ideas are they really testing me on here? Is it about cause and effect, a scientific model, a field? Second, link that idea to the specific topic you've learned. Finally, and this is the real mark winner, use the language of the key idea in your answer. So instead of just saying current flows, a top-level answer says the potential difference drives the flow of charge. See the difference? That shows the examiner you get the deep principle behind it.
Ultimately, what this all shows us is that this little section of the spec isn't just another page to memorize. It's literally AQA's guide to thinking like a physicist. When you start seeing these patterns and using this language in your answers, you are showing that deep understanding that gets the top marks. So, I'm going to leave you with a challenge. As you revise every single topic from now on, whether it's forces, waves, or space, ask yourself, which master key unlocks this concept? Try to spot the hidden idea. Because I promise you, once you start seeing these connections, the entire subject will just click into place.